So going back to our knowledge, today we will again do the equilibrium of electric dipole when placed in a uniform electric field, which we have just now derived the formula tau is equal to P arrow cross E arrow, P vector cross E vector, P E sin theta is its scalar value or the magnitude part. Okay. Now, what is equilibrium for rotational motion? If a body has tau is equal to 0, then we say that the body is in rotational equilibrium. We already know that when we place the dipole in uniform electric field, it rotated, correct? Because of the tau experienced by it. Now we are saying that when will it be in equilibrium? When will it not rotate? Only when tau is equal to 0. So that condition in which tau is equal to 0 for a dipole when placed in a uniform electric field is called equilibrium. Okay, rotational equilibrium also can be said. Don't confuse with the word rotational there. Fine. Rotational equilibrium means tau is equal to 0. That should be in your mind. That's why I have written them together. Fine. Now, let us take the case 1 in which theta is equal to 0. Let us see that tau is 0 or no. So, let us substitute. Tau is equal to P sin 0. Now, what is sin 0? Sin 0 is 0. Okay, sin 0 is 0. So, what is our answer? Tau is equal to 0. So, we know that this status is in equilibrium. But which kind of an equilibrium again? Stable equilibrium. Why? What is this stable equilibrium? What does it mean? That if I shift the dipole from the equilibrium position and leave it, it will come back to its original position. Let us see it diagrammatically in rough. What did I say? That this is the uniform electric dipole. I said this just now. Sorry, this is a uniform electric field. I said this just now. So I have placed them with or drawn it with the, shown it with the parallel lines equidistant from each other. And I have placed where theta is equal to 0. So theta is between what and what? Between the dipole and the electric field. How can I say theta is between the dipole and the electric field? What is the direction of a dipole? From negative charge to a positive charge. So I have placed the electric dipole such that the direction of P vector and E vector are same, such that the direction between E arrow and P arrow is 0. So the dipole is in equilibrium. Which equilibrium? Stable equilibrium. Why stable equilibrium? Because at this position, now just you think this is a dipole. Now, if I shift it, leave it, then this dipole will definitely come back to its original position. Then it is said to be in stable equilibrium. Fine? Okay? Now, case 2. So, for this case 1, theta is equal to 0. I have to place the dipole in the direction of electric field. Now, case 2. Let me place theta is equal to 90 degree. Let me write the formula again. What is sin 90? 1. So maximum value of tau will be achieved. That's why I'm writing tau max when sine 90 is equal to 1. That means I have placed P and E perpendicular to each other. So remember, this also is a PYQ. When do I get maximum torque? Only if I place the dipole perpendicular to the electric field, uniform electric field. How do I place it? Again I draw the uniform electric field as parallel lines equidistant from each other. I want to place the dipole perpendicular to the electric field. How do I place it? I just place it perpendicular to the dipole to the electric field such that P arrow, direction of P arrow. What is direction of P arrow? From negative to positive. So direction, this is the dipole, plus Q and minus Q. This I have drawn the direction of P arrow, which is perpendicular to E arrow. That means the vector E and the vector P are perpendicular to each other. You can see here it is a 90 degree. Any line you can take. Fine. So fine. When I do this or place the dipole in this way or this way, let the positive go up or negative come down, or negative go up or positive come down. That is not the issue. 90 degrees is I am placing the dipole perpendicular to the electric field. Then the torque which I get is maximum. Fine. Okay. So it is not in rotational equilibrium in this position. Fine. Now I go to another case, that is case 3, where I say theta is equal to 180 degrees. Let me substitute tau is equal to PE sine 180. What is the value of sine 180? Value of sine 180 is again 0. So tau is equal to 0. So again I got rotational equilibrium. Correct? So the dipole is in equilibrium, but which equilibrium? Unstable equilibrium. Okay? So what is unstable equilibrium? I will draw and show. Again I will consider the uniform electric field. And place the dipole 180 degrees with electric field. How do I place dipole with 180 degrees electric field? All are E. Okay, how do I place it? I place negative Q here. Here I place positive Q such that this dipole's direction is opposite to the direction of electric field. Direction of electric field is towards the right. Direction of the dipole is towards the left. That's why the angle between them is 180 degrees. That's why we get tau is equal to 0, which is considered as equilibrium for rotation. But this kind of an equilibrium is called unstable equilibrium, because at this position now if I turn it, instead of going back to its original position, it will keep rotating. That's why it is called as unstable equilibrium. This was stable equilibrium. If I displace this and leave it, it will go back to its original position. That's why stable equilibrium. This is unstable equilibrium. If I displace it, leave it, it will not go back to its original position. It will keep changing its position from there. So we have considered 3 cases. Case 1, theta is equal to 0. Stable equilibrium, tau is equal to 0. You have to remember. Theta is equal to 180 degrees. Equilibrium but unstable. Theta is equal to 180 degrees. That has to be remembered. These are PYQs. When do you get an equilibrium? Tau is equal to 0. When do you get a stable equilibrium? when tau is theta is equal to 0. When do you get an unstable equilibrium with theta is equal to 180 degrees? A complete 2-mark question it is. If you want, they can ask you diagram, you can draw. Fine. And when theta is equal to 90 degrees, we get tau max. This is also a PYQ. Maximum torque we will get when we place the angle between P arrow and E arrow 90 degrees. Fine. So I'll just move. You have to relax and understand. All these are PYQs. Remember, like a package. The moment the question on a torque has come, these three things or these three concepts have to come into your mind immediately. I'll just move and you take a screenshot. Fine.